A city of almost 27,000 people drinks its tap water straight out of a volcanic crater. Not from a river fed by one, not from a reservoir built near one, straight out of the crater itself. And that crater belongs to the youngest volcano on the Australian mainland. The word mainland matters. Far out in the sub-Antarctic, on Australia's remote Heard Island, there is a genuinely active volcano called Big Ben. Its summit vent, Mawson Peak, is one of only 2 places in all of Australian territory still erupting today, and it last stirred as recently as 2021. So when people call Mount Gambier the country's youngest volcano, that only holds if you stay on the continent. But this one never built a mountain to warn anybody. It blew a hole in the limestone, the hole filled with the bluest water in the country, and then it went quiet. And here is the twist. The story isn't that a town happened to grow up beside an old volcano. In Mount Gambier, the second largest city in South Australia, the volcano is the town. It is the most beautiful landmark for hundreds of kilometres. It is the drinking supply piped into homes right across the city, and it may not be finished. 26,878 people at the last census, living inside the blast radius of the most recent eruption this continent has ever seen. So why is there no mountain? Most volcanoes announce themselves. Magma rises, lava piles up, and over centuries you get a cone, a peak visible from a long way off. Mount Gambier did the opposite. It dug downward. The reason is water. Beneath this whole region sits the Gambier limestone aquifer, a shallow, porous, easily recharged layer of stone soaked like a sponge. When a batch of basaltic magma pushed up from the mantle toward the surface, it didn't reach open air first. It slammed into that groundwater. And when hot magma meets water, the water flashes instantly into steam and expands hundreds of times over in what geologists call a phreatomagmatic eruption, which is really just a fancy name for a steam-driven explosion. That blast didn't build anything up, it excavated. It punched a set of broad, shallow craters straight down into the bedrock. A crater like that has its own name, a maar, a hole blown out by steam rather than a hill piled up by lava. You can see the alternative just 14 kilometres to the south. There, a volcano called Mount Schank, fed by the very same kind of magma at almost the very same time, built a textbook cone, a neat 100-metre hill with a 300-metre wide crater scooped into its summit. Same fuel, different plumbing. Schank had less water in its path, so it raised a mountain. Gambier had an aquifer in the way, so it dug a hole. The word mount in Mount Gambier is really the rim around an absence. That hole is startlingly young, but exactly how young is one of the most stubborn arguments in Australian geology. Published estimates for the last eruption range from over 28,000 years ago all the way down to a little over 4,000. That isn't sloppy science, it's a genuine trap. The earliest radiocarbon dates came from sediment inside the crater, sediment laced with ancient carbon eroded off the old limestone walls, which pushed the samples too old and made the eruption look far more ancient than it really was. Later work pulls the date much younger. Radiocarbon on charcoal buried beneath the ash, together with the magnetic signature frozen into the rock, points to somewhere around 4 to 4,500 years ago, while newer dates on plant fibres in the lake sediment land a little before 6,000. The methods still haven't even settled which of the two erupted first, Mount Gambier or its neighbour, Mount Schank. But the honest answer is clear enough. A few thousand years ago, most estimates clustering around 5,000, and it was the single most explosive eruption in the entire Newer Volcanics province. A full 4 on the Volcanic Explosivity Index. And here the cold geology turns human. The Boandic people, who have lived on this country far longer than any of these measurements, carry a story about an ancestral figure named Cratebull. Cratebull lit his cooking fire on the mountain, until water rose up out of the ground, drowned the fire, and became the lake. Read one way, that is a myth. Read another way, it may be an eyewitness account. If it truly records the eruption, that story is something like 5,000 years old, among the oldest surviving oral traditions anywhere on Earth. The tradition even carries a built-in warning. The shriek of a bird the Boandik call the bullin, said to cry out just before the ground erupted. A detail some researchers argue helps order these eruptions where dating alone cannot. Where the radiocarbon labs are still arguing, people who are standing right here may simply have watched it happen and remembered. Which brings us to the water that drowned Cratebull's fire. The Blue Lake has a secret of its own. For roughly half the year, through the cooler months, it sits a flat, unremarkable steel grey. Then, almost every November, it flips. Over a matter of weeks, the entire crater turns an intense, luminous cobalt blue, a blue so saturated it looks digitally enhanced. And it holds that colour right through summer until around February or March, when it drains back to grey. The leading explanation is a process called whiting. In summer, the surface layer warms to about 20 degrees. Dissolved carbon dioxide escapes, the water's chemistry shifts, and it becomes supersaturated with calcite, calcium carbonate. That calcite precipitates out as crystals too small to see, and they scatter sunlight in a way that throws the blue wavelengths back at you. The counterintuitive part is that there is actually more calcite in the grey winter water than in the blue summer water. The colour isn't just more stuff in the lake, it's a delicate optical trick of temperature, chemistry, and light. And it is not fully solved. Whiting is the best supported answer, but scientists still debate the exact recipe. How much is temperature? How much is the angle of the sun? How much is the life in the water? A city's postcard, and no one can completely explain it. That postcard is also the plumbing. Blue Lake isn't a scenic extra in Mount Gambier. It is the town's main drinking supply. SA Water draws roughly 3.5 gigalitres out of it every year, somewhere around 10% of the lake, and pipes it into ordinary kitchen taps across the city. People here brush their teeth with water from a volcanic crater and never give it a second thought. It is one of the very few places on Earth where a whole city pipes its drinking water directly out of the mouth of a volcano. And the same aquifer that made the eruption so violent is exactly what keeps the city alive now. Remember that limestone sponge, the groundwater the magma struck? It never went away. It still feeds the crater from below, refilling what the city takes out. Which is why a hole blown open a few thousand years ago hasn't simply dried up under the South Australian sun. The lake sits about 72 metres deep on average and around 77 at its deepest, cold and clear and constantly topped up by the very rock that once turned to steam and tore the ground apart. Each drop stays in the crater only about 3.5 years before the aquifer flushes it through and replaces it. The weapon and the water main are the same system. So is it over? It is tempting to file Mount Gambier under extinct, a dead volcano, a pretty ruin, a geology lesson with a lake in the middle. The science won't quite let you. The newer volcanics province, the vast field of more than 400 vents spread across some 15,000 square kilometres that Gambier belongs to, and which has been erupting on and off for more than 4 million years, is not classed as extinct. It is classed as dormant, sleeping, not dead. Across the whole field, the long-term average works out to something like one eruption every 11,000 years. And the most recent one of all was Mount Gambier itself. There is no dense early warning network trained on it. Monitoring falls to national and state agencies, Geoscience Australia and the State Geological Surveys, stretched thin across an entire continent. But here is the part that unsettles geologists the most. This is a monogenetic field, which means each eruption builds its own brand new vent and then goes cold forever. So the next eruption, whenever it comes, almost certainly won't reopen Blue Lake. It will tear a fresh crater somewhere else entirely, in a paddock, under a road, beneath a town that has no idea it is sitting on the fuse. Not the return of an old volcano, but the birth of a new one. The Bowendik told this story once already and carried the memory of it across 5,000 years. The ground here remembers, and so did the people. Mount Gambier drinks from the scar of its last eruption and calls it the most beautiful place in the state, living quietly on borrowed geological time. The only real questions left are where the next hole will open and whether anyone will notice it coming the way the Bowendik once did. If you want more of the Earth's quieter violence, there's another story here we think you'll want to see.